Looking at 7-9, we are rounding again, which is something that we did way back at the beginning of the year. We're starting by rounding to the nearest tenth. And if we remember, what we first want to do is we want to be able to recognize that place value. So here's the tenths place. We have ones, tenths, hundredths. So there's our tenths place. Once we know where our tenths place is, we look to the right of the tenths place. And remember, if that number is 0, 1, 2, 3, or 4, the underlined digit stays the same. If that underline, or if the arrow is pointing to a 5, a 6, a 7, an 8, or a 9, the underlined digit goes up. So in this case, 2 is right here, so our underlined digit stays a 4, and so it just stays 4 tenths, or 0.04. Here, if we look to the right, it's pointing to a 6, which is here, which means our underlined digit goes up. So now we have 0.6. Here's our underlined digit, and we just said that it goes up, so it goes up to a 6. Here, even though it lists all the way out to the thousandths place, it doesn't matter because we're still only rounding to the tenths place. So we're looking to the right. What's to the right of the 8 is a 4, so our underlined digit stays an 8. And then finally, we have where we're looking to a 2, and here we're back to the 2 here, and so our underlined digit stays a 9. Now we're going to actually look at the assignment, and this is 1 through 4. We're going to underline our tenths place again. So there's our tenths place, and we're going to look to the right. And if we look to the right, the first one is an 8, which is here, which says that our underlined digit is going to go up, which means for number 1, we go up to 4 tenths. Here we look to the right, and it's a 4. Here's our 4. It says that our underlined digit is going to stay a 9. We look to the right. It is a 2, which means our underlined digit is going to stay, in this case, a 6. We look to the right. It is an 8, so it says our underlined digit is going to go up, and in this case, it's going to go up to a 1. For 5 through 8, once again, we need to determine our place value. We have tenths, hundredths, thousandths. We're rounding to the hundredths place this time, so we want to underline the hundredths place. Then, once again, we look to the right, and this time it's a 5, so our underlined digit goes up. Just the underlined digit. The first digit, this is going to stay at 2. So we're going to have, 0.2. We said that this 8 is going to go up, and then we're done. We've now rounded to the nearest hundredth, tenths, hundredths. Once again here, we're going to look to the right, and it's a 6 this time, which again means that that underlined digit is going to go up. So the digit before stays a 1, but then the underlined digit goes up to a 2. We go to the right of the 0, and that is a 9, and so the underlined digit is going to go up to a 1. This 7 will stay a 7. The underlined digit goes up to a 1. And then finally, if I look to the right of my 6, it's a 3, and it says a 3 is going to stay. The underlined digit is going to stay. So our 5 automatically stays. Our 6 stays because it told us up here the 3, the underlined digit, stays the same. For 9 through 12, they're asking you to figure out whether or not your answer is close or not to make sure that your decimal points are going in the right spot. So the first one I did for you, but if we look at the next one, we're taking 8.1 and saying, okay, 8.1, when I round that, is pretty close to 8. 4.2 is pretty close to 4. 8 times 4 is, and this, remember, means a little squiggly equal sign means approximately or about 32. Now I'm going to take this, and it's asking me for an exact answer, and I'm going to do it down here, 8.1 times 4.2. I'm going to do my workout. Two, three, four. My pen is being finicky. And then remember, I went over one place value and one place value for a total of 2. So I have 1, 2. My decimal point goes here. And I look to see, is 34.02 pretty close to 32? And yes, they are. If I'd put my decimal point in the wrong spot, if I'd put it maybe over here instead, 340 isn't close to 32, so I would have known that that decimal point was incorrect, and I would have either re-looked at my problem or redone the whole thing. So here, once again, I'm rounding to the nearest whole number, which 7.65 is close to 8, and 0.99 is really close to 1. So my answer is approximately going to be 8. Now I have to take this ginormous number and this one and multiply them together. So I've done my work, and I look here and I went over 1, 2, and I went over 1, 2 to get to my decimal point. So my answer has to go over a total of 4. So it's going to go over 1, 2, 3, 4, and my actual answer is 7.5735. And then I want to look, because it's going to help me know if I put my decimal point in the right spot. Is 8 pretty close to 7? And it is. If my decimal point, if I'd accidentally put it here, if I'd miscounted and said that my answer was 75.735, 75 isn't close to 8, so I would have known I'd done something wrong with my decimal point. If I look at this next one, 3.8 is really close to 4, and 6.02 is close to 6. When I multiply those together, I get about 24. So now when I find my real answer here, we'll see if it's close to 24. I got 22,876. I went over 2 decimal points and 1 decimal point. So in my answer, I need to go over 3. So I go over 1, 2, 3, and my decimal point is here. I'll write my answer in, and I'll look and I'll say, all right, is 24 and 22 pretty close together? Yep, so my decimal point must be in the right spot. Finally, on the last 2 problems, we have our word problems. A factory makes 394 motorcycles each week. If there are 52 weeks in a year, how many motorcycles will the factory make in a year? Remember, even though we know we're in a multiplication unit, we want to say, okay, why are we multiplying these 2 numbers? Well, each helps us know, and we want to know how much for a whole year. So if we're thinking, okay, the first week is 394, the second week is 394, the third week is 394, and so on. Repeated addition is the same thing as multiplication, so we know we're multiplying. So I have my estimate of 394, and I'm multiplying it by 52. I want to estimate that 394 to 400 and the 52 to 50. And then I'm going to take 4 times 5 is 20, and then I have 1, 2, 3 zeros that I'm going to add on. So my answer is going to be somewhat close to 20,000. And you look at our answer, and our answer is 20,488, which is very close to 20,000. For number 4, it's asking, suppose you want to buy 3 CDs for $18.95 each. Should you make a safe estimate or an ordinary estimate to find out if you have enough money? What would be a good estimate of how much money you will need? If you have $55, you have enough money. In this case, of course, we want to make a safe estimate because you don't want to go up to the cash register and not have enough money. So we're going to round these up to $20, and we could think we have 3 CDs and they're each $20, so we could say, oh, repeated addition is the same thing as multiplication. So we could multiply 20 times 3, or we could just add it 3 times since it isn't a very big number. Either way, we're going to get $60. So if our estimate is $60 and we have $55, we obviously don't have enough money. Looking on the remembering side, we see that where we're having equivalent fractions and decimals, these are the 4 big ones that we need to know. For number 1, our answer is bam, right there. For number 2, we have 9/10. If we know what 1/10 is, we can figure out what 9/10 are because we can just multiply the 1/10 times 9, and then we get 0.90 or 0.9. For 4/8, two different ways to do this. You could say that 4/8, and you could remember that 4/8 is the same thing as 1/2. And we all know that 1/2 is the same thing as 0.5. But if we didn't think about that, if we know what 1/8 is, then we can figure out what 4/8 is by taking 0.125 and multiplying it by 4, and you get the same answer. So this is our answer for number 2, and this is our answer for number 3, either one of these, and they're both the same. And then number 4, again, if we know what 1/5 is, we can figure out what 2/5 is by just multiplying by 2, and we get 0.4 or 0.40 for 2/5. We're lucky because on our assignment it doesn't ask us to put our decimal as a fraction in simplest form. So all we're doing is putting it as a decimal. So this, remember we have tenths, hundredths, thousandths. So here is 2/10. So all we're doing is 2/10. If we wanted to put it in simplest form, we could divide both parts of it by 2, and we get 1/5. They are equivalent fractions. 15/10 hundredths. 15 hundredths would be 15 over 100. And again, it doesn't ask us to do this, but we could divide both parts of this by 5, and we could end up with 3/20, which would be the answer in simplest form. Here we have 5/10. So we have 5/10 is our equivalent fraction. If we wanted to put it in simplest form, we could divide both parts by 5 and get 1/2. And then finally we have 75 hundredths. And 75 hundredths, if you remember our equivalent decimals, we should know this one just by, in our heads, should be 3/4.